Okay. Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad NAQIIB RITHAUDDEEN, and I will introduce my group members. AMIRUDDIN AKMAL bin SOLAS as a group leader. Next is Muhammad FARHAN bin SHAMSUR BAHARIM. And my name Muhammad NAQIIB RITHAUDDEEN. Okay, next. I will present to you Lab 1. Okay, Lab 1 is consume about Ohm's law. Uh, Ohm's law, what we know is about Ohm's law is V equal to IR. That is Ohm's law. V is a directly proportional to R, and R is inversely proportional to I. I is a current. Okay. Equipment we will use is DC power supply unit, PSU, conductor board, ammeter and voltmeter, or to flux ammeter to measure current, voltmeter to measure voltage, and LCR data bridge. Okay, procedure. Construct the circuit shown below with R resistor 470 ohm, 2.2 kilo ohm, 10 kilo ohm. Okay, basically in this lab 1, it required to make 3 circuits that have a different resistor value while increasing volt from 1 to 8 volt. Like that. Okay. Yeah. Okay, next. Okay, this is simulation. If you can see, this is our voltage supply. First starting with 1 volt, and it directly to this R1 resistor 1, 0.47K. Okay, first circuit we using for 0.47 kilo ohm. Okay, and this is the result. For first volt, this is the ohm, this is the current. For second volt, this is the current. If you can see here, the current increasing because the volt increasing. That's why volt and the current is directly proportional. Same as volt increasing, current also increasing. Next, the same until the 8 volt. The current is still increasing. Okay. For second circuit, we increase the resistance. Okay, so when we increase the resistance, the current should be lower because the current and the resistance is inversely proportional. Okay, we can see here same method. We just use same concept, increasing volt 1, 2, 3, 4, and 5, and the current is still increasing because we increase the volt. But when we compare to the before this, the value of current decreasing before this because we increase the resistor. Same. They will increase, still increase. Okay, for circuit 3 also the same. We increase the resistor, and the current should be lower than before the circuit, and it increased step by step because we increase the volt. Actually, this lab is primarily for the explain the Ohm's law, V equal to IR. That's all. Okay, next I will pass to Farhan.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FARHAN bin SHAMSUR BAHARIM. So today I'm gonna present to you guys about the lab 2. So the objective for lab 2 is to compare calculated with measured values of voltage and currents in a series parallel DC circuit. So we want to compare the voltage and currents that we calculate with what we measure using a real circuit. So the equipment that we use is power supply, 20 volt. The breadboard is for the constructor board. Voltmeter and ammeter is to measure. And lastly, the LCR data bridge. So for the procedure, for the first one, we construct the circuit, then state the color code for each register, and then measure each register value using LCR bridge, which assume the value match what we expect. And last one is to calculate voltage and current using formulas. Okay, next. So this is the table for the register and the color code. So the how the circuit is connected is R2 and R3 are in each series, 1680 ohm. R4 and R5 is 860 ohm. Then those two, R2 and R3 and R4 plus R5 are in parallel. So R1 is in a series with the parallel part. So for the total resistance, R1 plus parallel equals to 900.75 ohm. So total current from power supply, 20 volt, is I equals to 20 times 900.75 equals to 0.022 ampere. So voltage across R1, 22.2 milliampere times 330 ohm equals to 7.33 volt. Voltage left for parallel part is 20 minus 7.33 equals to 12.67 volt. And the current through R2 and R3, 12.67 bahagi 1680 equals to 7.54 milliampere. And lastly, current through R4 and R5 equals to 12.67 bahagi 860 equals to 14.73 milliampere. So next, the simulation output. So on the left side, we have this circuit diagram from LT Spice. It shows the same resistor values and a 20 volt source. So the right side is the output table. It shows the voltage and points in the circuit. Show currents through each resistor. And so the current through each resistor for the R1 is 15.9 milliampere. R1, okay, R1. So the R2 is 8.5 milliampere. My bad. So the R2 is 0.0085 milliampere. So R3 and R4 is 7.4 milliampere. R3 and R4. Okay. So for the conclusion, we built the circuit, calculated the current voltage, and ran a simulation. And the values from our math and simulation are very close. This proves our understanding of series parallel circuit is correct. So that is for lab 2. So next one, I'm going to pass to Ame. Okay, thank you.
Hi, I'm AMIRUDDIN. So I will be talking for lab 3. So lab 3, our objective is to measure and calculate a circuit for a series parallel circuit and verify the superposition theorem. So the equipment we'll be using is a construction board, a DC power supply with 10 volt and 12 volt, a digital multimeter with a LCDR data bridge. So the procedure here is to connect both, first to make a full circuit that can have 10 volt and 12 volt and read the currents for R1, R2 and R3. And then next we're going to take out we're going to read for only 10 volt, and then next one we're going to only read for 12 volt. So for the first output circuit, we can see this is the one we have 10 volt and 12 volt, V1 and V2, and all the resistor on read with the result on the right. We got R1 with negative 0.03, R2 with 0.04, and R3 with negative 0.007. And then we have our V1 and V2 ampere result as well. as you can see stated on the right. Next, we're going to the next circuit where we take out V2 12 volt and only have 10 volt and read the result with the ampere as well. The result that we got from the simulation is for R1 is negative 0.08, R2 with negative 0.04, and R3 with negative 0.03. Next, we will go ahead and look at the last circuit, which will take out V1 and place back V2, the 12 volt. R1 we have 0.05, R2 we have 0.009, and R3 we have negative 0.003 as the ampere reading from the simulation. So this exercise application for superposition theorem in analyzing multi-source DC circuit we're able to measure and calculate the current in each branch of the series parallel circuit and verify the superposition theorem. So next we will go to lab 4. Lab 4 objective is to calculate the Thevenin equivalent of a given circuit and verify the Thevenin theorem through measurement and comparison. So for the equipment, we have a construction board, a DC power supply with 10 volt and 12 volt, a digital multimeter, and an LCR data bridge. So for the procedure, step 1 and step 2, we're going to construct a full circuit and measure the circuit with R1, R2, and R3, with R1 containing 680 ohm, R2 containing 820 ohm, R3 containing 1 kilo ohm. And then step 3, we're going to have an open circuit voltage. So we're going to remove 1 kilo ohm resistor and measure the voltage across a terminal A and terminal B. You will see it soon. And this is going to give us our theorem voltage. For the theorem resistor, which is R, we're going to remove both 10 volt and 12 volt source and replace with a wire link with the 1 kilo ohm also removed, and measure the resistance between the terminal. So this will give us our resistance. And then the next procedure, step 5 and 6, we will calculate the values. This will give us our V and R. And then rebuild the Thevenin equivalent circuit. Connect the 1 kilo ohm load across the A and B bridge again. And step 10, calculate the terminal voltage, use the formula given. So on our right, we have the first procedure, the first step of the part of the procedure, where we have all of the circuit connected, and then we have our result on the next page. Here we got R1 with the 0.003, R2 with 0.004, R3 with 0.007. And then we're going to go ahead to the next procedure. This is where we remove the 1 kilo ohm resistor and place it, have the readings on A and B. And the result on the bottom, as you can see, we got the R1 with a negative 0.014, R2 with 0.014. It is close and similar, but one is negative, but both of them are similar. Lastly, we have the one where we remove the voltage and have the back in the middle between the back with the 1 kilo ohm resistor back in the middle. So here we have the resistor read as 0.014, negative 0.01, and then the resistor by right, it should be negative 0.0026, as you can see on the right side. So in conclusion, the Thevenin theorem states any two-terminal linear network can replace with equivalent circuit consistent of a single voltage in the series it's with. So can the dividend be used with two sources? Yes, it's a valid for any number of sources as long as the circuit is linear. That is all. Thank you very much.